An essential element of a production install of Kubernetes is maintaining application and system logs. It is necessary to have an external system to maintain logs because 1. The generated log size could be huge and hence searching through the logs might need special tools. 2. The log size may increase over time and an efficient storage, retrieval, and archival system is important. 3. There are various kinds of logs such as application logs, access logs, and system logs. We need a centralized place to look at all logs. 4. The production support might need to be given access to look at logs without being given access to the actual cluster. 5. The logs need to be preserved even if the application crashes or gets deleted. All of the above problems can be solved by using an efficient logging system. Kubernetes itself does not provide a logging system, but we will look how to leverage Fluentd, Elasticsearch, and Kibana to store and query logs. We will now look at different ways to handle logging at the cluster level. The first way is to use a logging agent per node. Each node installs a pod that has a logging agent whose job is to read all logs in the node and send them to the backend logging. For example, we can install Fluentd as a daemon set so that it can read logs from each node and send it to an external software such as Elasticsearch or Splunk. We'll look at a demo of this later in this video. The second way is to use a sidecar container that sends logs to standard output and error. This can be used for applications that do not log to standard output directly, or if you have multiple logs in an application and you need to combine them in one stream. The third option is to use a sidecar container that sends logs to the backend directly. In this case, a sidecar agent in every pod would send data out of the node. This method is probably not very optimal since it can use a lot of resources. The last way is to directly send logs from the application to the logging backend. This will require modifying the application and may not be suitable for all kinds of applications. Also, this does not give us access to system logs. We will now set up a logging framework using Fluentd Bit, Elasticsearch, and Kibana. We begin by creating a cluster in AWS using KOps. We have covered this in an earlier video. To start the cluster, we set the name variable, set the KOps state to the S3 bucket, create the cluster configuration, and then tell KOps to create the cluster in AWS. This might take a while to start, but at the end of it, we should have a 3-node cluster with 2 nodes and 1 master. After the cluster starts, we begin installing the various components starting with Elasticsearch. For a production install, we would install a multi-node Elasticsearch cluster, but for our demo, we will install a single node cluster. Note that it's not required to install Elasticsearch inside the Kubernetes cluster. It could be installed and managed outside the cluster too. In larger enterprises, there are chances that your company already has a logging backend in place. We will install all components in the logging namespace. Create a namespace using kubectl create namespace logging. To install a single node Elasticsearch, type in kubectl run -- generator to specify the API version, image name, and version. Pass in an environment variable to run single node, port is 9200, and namespace is logging. This creates the Elasticsearch pod. After a while, the pod should start. To access Elasticsearch outside the cluster, we create the node port. Let's check the port number. We now need to change the security groups in AWS to allow the node port. As seen in this screenshot, we have added rule to allow port 30354 from everywhere. We will now call Elasticsearch at any node ID and port. Elasticsearch has started fine. Next, we install Kibana. We need the cluster IP of Elasticsearch so that Kibana can talk to it. To install Kibana, type in kubectl run generator, image name is Kibana. In the environment, we pass in the Elasticsearch URL, which is cluster IP :9200. Remember that within the cluster, we can access services using cluster IP, and outside the cluster, we need a node port. Let's check the Kibana logs to see if it has started and connected to Elasticsearch. Kibana seems to have connected. We now create a node port for Kibana. Similar to Elasticsearch, we allow this port in the security group. Next, we need to install Fluentd. FluentBit will be installed as a daemon set so that it runs on all nodes. The first step in installing FluentBit is to create a service account for FluentBit, followed by role and role binding. Use the files from the GitHub directly. Next, we need to create the config map. However, we will need to update the config map and add the Elasticsearch URL and port. After editing, create the FluentBit config. Similarly, download FluentBit DS file, modify the Elasticsearch URL and port, and then apply it. This will create the pods for FluentBit. It will create 3 pods, one in each node. Once the FluentBit pods have started, we create the hello daemon set. While the pods are starting, we go back to Kibana and configure the index pattern by using the default index pattern and selecting timestamp field. Click on Create. This will create the index and we should be able to see all Kubernetes logs. Let's search for the logs of our hello daemon set. We add a filter for that pod by using the pod name. We now have the logs for all our pods. Let's zoom in to see if we can see the string hello. The logs from our pod are reaching Elasticsearch. One last thing before we end our video. The configuration for FluentBit is specified in the config map file. Here's part of that file. The first configuration is in var.log directory and the file contains many more. We can modify this file to add additional logs. Don't forget to delete the cluster once you're done. This finishes our demo on logging. If you want a production grade install, use hem charts to install Elasticsearch and Kibana. Everything else should work the same. In the next video, we will look at monitoring. See you in the next video.